The reason you're watching this video is to learn about creating a unit circle. And there's a couple of things as far as background. Why do we do it? A unit circle is a way to kind of understand the sine, cosine, tangent of angles that are greater than 90 degrees and also less than or equal to 0 degrees. In the triangles we've used so far, all of our angles have to be greater than 0, less than 90, because they're dealing with right triangles which have a sum of 180 degrees. Also, we use this when we start doing graphing of the trig functions. We'll be talking about that a little later on. So those are the two main reasons why we actually do this, or two of the reasons we will use them for. So as we reviewed in class today, you have the two special reference triangles you'll need. The 30, 60, 90, we'll be using that. Remember the ratios here. If you base, the side between the 60 and the 90 is 1. What would be the other leg, I should say, is the square root of 3. Hypotenuse is 2. In your 45, 45, 90, in that one, each one of the legs is 1, and the hypotenuse in this case here would be square root of 2. So we're going to be using those two triangles as well. So if you have those handy, you'll be using those in a little while. All right, so to start with, when we create a unit circle, it is a circle with a radius of 1. All right, so unit circle is a So you have this circle of radius 1, and what we're going to do is there's some points picked around the circle, and this is the handout that was given to you, which you'll see on the next slide. When we're done with this, each point will have a degree measure by it. Excuse me. Each one will have a radian measure for that point, so the measure of the angle there, and also a coordinate that goes with that if this was in a coordinate plane. So to move on to the unit circle here. So if we're going to do this, as I mentioned, each one of the points is going to have a degree measure. So we're going to start with that. We're talking about the degrees starting from basically right here. You don't want to draw this part in, but we're talking about degrees when we find the point that's marked right here. We're talking about the measure of this angle. So if I'm talking about this point over here, when we do the angle, we're talking about the measure of that angle right there. So we'll be going through each one of these and coming up with the degree measure for each one of them. So to start with, when you start off, if you think of the line being directly in this spot and moving not at all, obviously that is 0 degrees. Now I'm going to just break this down in kind of a common sense way, not just going step by step, but if you think of your circle, if you go halfway around a circle in degree measure, that is 180 degrees. So you should have that marked on there. Each one of these things I write on now, you should have these labels. Now again, as we start, if you think about that halfway in between here, obviously this dot is going to be 90 degrees. Down towards the bottom here, this will be 270 degrees. As we go 90, there's 180, we move another 90 degrees, and to come all the way around, 0 again could be 0 or 360 degrees. So if you have that set up so far. Now, if you go back to your unit circle and you start thinking about this spot right in here, it is actually on our unit circle. It's halfway between the 0 and the 90. That spot right there, of course, is halfway between 0 and 90, 45 degrees. Okay, halfway between 90 and 180. That's going to be a total of 135 degrees. You may notice, it's just counting by 45 degrees each way, each step. And again, now if you figure, 45 degrees more than 180, or halfway between 180 and 270, you're going to find that's 225 degrees. Then if we move on to this final point over here, halfway between 360 and 270, 315 degrees. All right, so now we've started with our degrees. Now we're going to move on to looking at what would be the rest of these angles in here. All right, so those angles then at this point, we realize the distance to the first one, this is actually divided into three parts. There's 1, 2, 3. So if you're dividing into three sections here, the measure from the 0 up to here is actually going to be 30 degrees. You go another 30 degrees, you're up to 60, and then this would be 90. Count another 30 degrees, you're at 120, 150 degrees. Then that gives us the 180 there. We go another 30 degrees, that's 210. Another 30, we're up to 240 degrees. Now we've moved to 270. So then that one's already marked. Go another, that's 300 degrees. Going another, that is 330 degrees, all the way back to 360. So at this point, we've marked all the degrees. Now if you start thinking about radian measure, that's going to be our second step. To measure radians, remember you can have, this is the distance around the edge of the circle using the pi. Again, we said this would be 0. Now these you're also going to mark in. Now here's your radian measures that we're going to put in. That's 0. If you go all the way around, remember this is 1 unit. Again, 1 unit is the radius. The distance around the circumference is pi times d, in this case, which would be, the radius is 1, diameter would be 2, so it would be 2 pi, or 2 pi r, so you can give the same result. Okay, so we got 2 pi, or 0 or 2 pi. If we start at 0, go all the way over to here, 180 is actually pi. That's what we talked about before. 90 is going to be, actually you see is pi over 2. All right, so now if we just think of, we have cut into parts here. We have 1, 2, 3, 4, 5, 6, different parts here. And we're going to take pi and divide it by 6. Well, that means that's pi over 6. 30 is going to be pi over 6. Or you could use, just like we did in class, and convert those. Well, pi over 6, another pi over 6. If you have 2 pi's over 6, that is going to be 2 pi over 6, which is same as pi over 3. So you do the same thing. A half pi, that's like 3/6 pi. Well, that means if that's 3/6 pi, this would be 4/6 pi, which is the same as 2 pi over 3. Now we're going to move on to the 150 degrees. Well, that's 4. This would be 5/6 pi, or 5 pi over 6. That doesn't reduce. Going on to the next one where we have pi. That's, just one more 6. 6/6 is 1. All right. So we're going to continue on here all the way around again. So now you have 6/6. This would be 7/6 pi, or 7 pi over 6. Moving another, that gives you 8 pi over 6. Adding another 6, well, that just reduces to 4 pi over 3, just dividing the top and the bottom by 2. If we move another pi, this becomes, what we would have here is 9/6 pi. Okay, that right there, again, as you know, reduced to 3 pi over 2. Moving another one, so we had 9, so now we have 10/6 pi, which reduces to 5 pi over 3. Going another, we have 11 pi over 6, which can't reduce. You add one more 6, you get 12/6, which is 2. So at this point, what we have so far is we've come up with all the radian and degree measures. Now, to have enough time to come up with the rest of it, we will be looking at, what are the coordinates of each one of these points. So in that case, you're going to need your reference triangles. So if you don't have those, please get those available now. All right, so to come up with the coordinates, what I'm actually going to do is start that on another one of the videos, because of our limitation of the 15 minutes here. It might take slightly more than that. So at this point, you should have this part down and go on to the next video where we will talk about how you can find each one of those as far as the coordinates if this wasn't a coordinate plane.